Okay, so from that, we also have mixed encryption mechanisms. How do we go with this?
Well, mixed, we can do whatever we want, right? This symmetric encryption, asymmetric encryption are tools, right? We can do whatever we decide to, but there is a catch for public cryptography. It's much harder to compute, right? So with symmetric encryption, you have a much faster two-way mechanism to encrypt and decrypt, right? With asymmetric encryption, there is a lot of math involved in it. So it requires a lot more resources. And if you want a communication that is very bandwidth intensive, or
Yeah,
you want to have a channel to go back and forth.
yeah, you have that example that where you need performance, like you are browsing on the web, and if it's HTTPS, it will be encrypted by nature. So and you can see how fluid it has to be for you to have a good web good browsing experience. It has to be really performant. So yeah, you need that. You need that performance in like daily. It's not just for crazy stuff.
Yeah, and also if you are working with some, like for instance, SSH connection to your server, you want it to be more or less fast, right? But you want to be secure anyway.
Yeah.
So there is a lot of mechanisms that require that both types of encryption. Usually, like for instance TLS, which is the encryption used in HTTPS or email or whatever. Usually, what this means is that there is an initial handshake mechanism which is based on asymmetric encryption, right? I share my public key, the other side shares the public key. We both create an handshake mechanism for us to get together somehow and know that we are exactly each other because we sign stuff, and they are able to verify signatures and see, okay, this is...
Yeah, it goes through several steps, right?
Yeah.
The server asks the client, well, which ones do you support? And then you say, well, I support these ones. And then the server, well, I have these ones. Well, it's the handshake is like it's several.
Yeah, and then
several steps.
when both parties are validated, they are able to choose a symmetric protocol to communicate with, right? And choose a key.
Yeah.
And that communication channel is already encrypted with the asymmetric encryption. And then I choose the key and the protocol to continue the communication in another channel encrypted with the single symmetric key, which is faster, right? So in case of HTTPS, this is done on a connection establishment, right? When the client connects to the server, and then the agreed key, is maintained all through the life of that communication channel until it is closed by timeout or whatever. So, or by intention. So, and then when another communication channel is opened, another key has to be agreed upon during the handshake, and that's it, right?
Yeah.
So mixed encryption is like this. It's for performance reasons, and it's usually like this. On SSH is the same thing. They agree on an asymmetric encryption key, and they use that back and forth for the terminal operations and stuff like that. So, yeah, this is it. I think mixed encryption mechanisms is we talked about.
We were talking about the use cases for this, and you mentioned email encryption.